So in this class today we are going to see about a particular sensor that actually used in lot of prototype projects. Okay, you may have this type of sensor that you are seeing in my screen, that is ultrasonic distance measurement sensor. Okay, it is used to measure the distance of some object within a range, particular range. Okay, so why we are saying about this sensor? Because we are going to use this sensor in our project, and also these sensor like used in lot of IoT projects. If you are in future, if you are developing some prototype, means mostly you should be like you will include this sensor. Okay, so like that this is a really a popular sensor, ultrasonic distance measurement sensor. Okay, so how it is working means like this is some circuit, we no need to consider. Let's see the principle how it is working. Okay, ultrasonic sensor measure the distance using the sound waves above human hearing. Okay, which means it is going to send particular frequency of sound. Using that it is going to measure the distance. Like I will show you how it is just measuring the distance by sending the sound waves. Like that I will show that how it is like measuring the distance by just using the sound. And actually the sound, it is sound waves it is going to use is above 20 kilohertz, so which is not audible for human. Okay, so when the sound wave is created using those sensor, using this sensor, we are unable to hear those sounds because the frequency of that sound waves is above 20 kilohertz. Okay, so the module that we are going to see is HC SR 04 like 04, like this one. This is a very popular one, and application is we are going to detect obstacle detection, and it is also used in parking system robotics. Like this they are using that. Like in these application we should know about distance related stuffs, so that's why we are using this sensor. And the advantage is it is non-contact. Okay, like you no need to just you need to fix in a particular position, and it is automatically measure you the measure you the distance. Okay, so this is how we are going to connect the ultrasonic sensor into our microcontroller. So we are going to connect that VCC, which means here you are seeing that we are going to connect that into 5-volt supply from the Arduino or some other microcontroller that you are using in your project. And trig means trigger input. Okay, like it is going to like start the measuring the signal. So that is why we need to set this pin as input pin. I will show you how it is working. Okay, echo pin is output pin, so we need to configure triggers input and echo as output. Okay, so there are 4 pins only, and ground we as usual connect to the ground of the Arduino or any microcontroller that we are using. Okay, so required components, one sensor and microcontroller and some necessary breadboard or wires. Okay, so how it is
Can you
yeah.
can you please explain the trigger and echo once again?
Yeah, that's what I'm going to explain now clearly. Like listen now, that is I'm going to explain. Here you are seeing that trig means input. Okay, and echo means that is we are going to like send some output signal. Okay, so how it is going to work means, here you consider it is echo. Yeah, it is echo and it is trig pin. Okay, what is echo is going to do is it is going to produce some echo like that. Like it will create a sound wave, and it is go in the like in air medium or some like that. So it will go to the like until the object reach, then the sound is reflected from the object to the receiver. So the receiver should be input, that is trig pin. Okay, here you are seeing trig means here, so that is the receiver here. Okay, hope you understand that one. Like just understand what we are going to do. You don't need to confuse about trig or echo. Okay, just understand. Here you are seeing that they are mentioning T and R here. Okay, you able to see from this, I guess, in the sensor. T means transmitter, R means receiver. Okay, transmitter is going to transmit some signal that is above, like it is like nearly 40 kilohertz, it is going to produce a sound wave. When I am placing some object here, something like car or a human even, or some other box, like that, any object, okay, so sound will go and fall on that object. The object will reflect that signal, sound signal, that is reflected signal. It is original signal, and we are getting the reflected signal from the object. Then the reflected signal reach the receiver, okay. With this mechanism, it is going to measure the distance only using the sound waves. Hope you understand how it is actually working internally. Just simple. When we are seeing with our human eyes, like, we are not able to see what is happening exactly, but it is actually doing. Also human ear also not hear those sounds, okay. That is the actual thing here. It is going to produce a sound wave that is above the human audible range, okay, so that we are not able to hear that. So when the transmitter is transmitting and object is it is it will for the signal will fall on that, then object will reflect that signal. We able to measure the distance, okay, using some formula that is internally happened in this module, okay. We don't need to worry about those. So sensor send a short ultrasonic pulse via trick pin, that is what I said. Actually, sorry, I said like trick pin actually sending the sound, okay. Here we are seeing send short like sensor send a short ultrasonic pulse via trick pin, okay. So here we are seeing trick means like transmitter, so that is going to send that. And echo means like we are send sound reflect back from the object, so that is echo, okay. And the echo pin stays high for duration of wave travel. So they are saying some mechanism how it is working. And time measured equal to distance calculator, okay. Like how much time it is how it is actually working means how much time it will take to receive the reflected signal. So that is using those it can able to calculate the distance, okay. Then coming to the formula that is internally happened in that module, distance equal to time into speed of the sound divided by 2. So using this it can able to measure the distance, okay. So that's how here they did some example calculation, okay. And timing diagram like a trick pin like that, here they are so showing how the pulses is created. So this is how we are going to work practically now. So and trigger pulse is minimum 10 microsecond high, and echo pulse high for duration of round trip. And MCU measure pulse width to calculate distance. It is just saying that diagram about this diagram, okay. So just we no need to worry those connection. And the internal circuit design is like this, okay. And how it is working, trig is digital output pin, echo means digital input pin. So like that, actually here echo is digital input pin, okay. So here they are mentioned wrong, I guess, in this diagram, because you can see here trig means digital output pin, okay, that is going to create a output signal. And echo means that is digital input pin, okay. So that is we need to receive that signal. So this diagram is like showing trig is input, but actually trig is output, echo is input. That is like initially I confused on this one. So so don't consider this diagram, okay. When we are working practically means, then you understand how we are going to do the connection, okay. So just let's see about that. We will open the Tinkercad now, because walkway like take too much time. So I just open the Tinkercad. There is already some available project, so just take that one. Yeah, here they are saying that now, yeah. Okay, here actually that same module they are using here for ultra that ultrasonic sensor. Here you can see how they are did the connection first. So VCC is connected to the VCC of the Arduino, and then ground is connected to the ground, okay. Now carefully see about this here. Here they are connected the trick pin into 10th pin, and echo pin into 9th pin. When we are seeing the code, trick pin is like how they are setting means trick pin is output pin. Okay, here you are seeing that trick pin is output, echo pin is input. So coming back to the presentation here, trick pin is output pin actually. So please correct this diagram when or else when I am sending that I will change this one. Okay, I will try to change, but understand trick pin is always like in presentation text I given the right one. You can see that here where I mentioned, yeah, trig is digital output pin, echo is digital input pin, but here only in this diagram we have some wrong here, so we need to fix that. Okay, so you don't need to worry about this diagram, so just use this circuit connection detailed this pin connection. Okay, so according to this we are going to actually do the connection, but here the connection is already done. Okay, so that is trick pin is 10th pin and echo pin is 9th pin. As usual we set that one like for where we are connected, and the pin mode also we set like trig is always output pin. Okay, mind that. And echo pin means like this one echo, this is going to be input. Okay, so trig is like transmitter and echo is like receiver. So like that you remember that one. Okay, hope that you are understand now. Now coming back to the program, so these all are simple one. Okay, these all we already know, just we are like declared the pin of trig and echo, and time and distance here we are like created a variable. Time is always like we don't need to worry about the like a point something like that, but for distance we should need the float, so that's why like point values, so that's why we are giving the float here. Now coming to the formula that we have been already seen in the presentation, distance equal to time into what they have given in that formula. Come to here, time into speed of the sound divided by 2. So that's what they are using here, time into speed of the sound divided by 2. Okay, speed of the sound like it is default in this HC SR04 module, so that's why they are giving some range of speed of the sound. And how they are creating the sound means here you can see digital write. Initially what they are doing, like they made the pin as trick pin. Here you can see, so this is output pin. They are making that as low initially so that no sound will pass from that. Delay microseconds they are doing. Okay, not normal delay, they are using microsecond delay for 2 seconds. So this is just for initialization. Then they activate the trick pin for 10 microseconds. Here you need to see carefully, trick pin, so this pin like transmitter pin going to transmit the ultrasonic sound for 10 microseconds. So then 10th pin is setting as low. 10th pin is means which is trick pin. Then after 10 second they making the trick pin as low. Okay, so that is they are using the 10 here, it is actually trick pin. Okay, trick pin. Okay, same here, they first activate that and 10 microseconds they wait, then they turn off the transmitter. Then after that we are like store this pulse in echo pin. Like echo pin is we are used that as input pin. Okay, so echo pin is going to be high and it is stored in the time variable. So in the time variable, when we are getting the reflected signal, it is stored into time variable. So that is here they are using some kind of form function calling here pulse in of echo pin comma high, then they are storing that into time variable. Okay, then they are using the serial monitor and they are printing the time here, so we no need to worry about that. Here they are using the distance formula, then they have been successfully calculated the distance. So this is how the sensor is working. Simple code, okay, no you need to complex this one. It is very simple to understand. So let's start the simulation, then you understand how it is working. Okay, actually they are having error here. Trick pin was not declared in the scope. Oh sorry, this is capped speed. Okay, now we will, yeah, so the simulation is running. Now I need to open the serial monitor. In serial monitor we are unable to see that like it is so fast running. Okay, so I am unable to see that one like clearly. So what I will do is I add a delay then, so that I am able to see what is happening. Delay of 1 second we will give that, like 1 second means 1000 milliseconds. Now let's start. Now we have able to see that one distance 203 centimeter or something like that. Time also they are giving some kind of time. We no need to worry about the time, we only need the distance. Here when I'm clicking the sensor, you have seen like this, you able to see like this. So this is the object. Okay, like just we consider this as object. So when the object is near means, here you see the distance is reduced. Okay, you able to see that one, I guess 90 centimeter only. So when I make the object so close, 40 centimeter only. So like that 28 centimeter, then here only 2 centimeter. So like that we need to, like here you can see 3 centimeter like that. But when the object is detected over long distance, we can able to see 300 centimeter. So like that we able to place anywhere. Anywhere means what it will do when the sensor is placed like vertically on that column wise, like you able to imagine, I guess. So actually ultrasonic will work when you are placing the ultrasonic facing some kind of direction on that particular vertical direction. You able to like the horizontal direction, sorry. So able to see those, like if the object is placed in front of this sensor, it will able to detect that one. But when you are placing the object like in this sideways or in this sideways, it is not able to detect. Okay, so we only able to get wrong values. If we want like the perfect value, we need to place in this range. That only the ultrasonic will work. Okay, in actually we are in simulation we are able to do like this, but in real life we don't have like we no need to worry about anything. Just we need to code like this and fix this into Arduino, and then we place sensor somewhere. So when you are placing some object in front of real-time object, any object, box or any kind of object, when you are placing that in front of the sensor, it will create a sound wave, and the object is it fall on the object and get reflected back. Then it will give you some distance. You can see that on serial monitor, or else you can see on LCD display when you are fixing that. Okay, so still serial monitor is a pending topic, I will explain that one, you no need to worry. So this is how the sensor is working. So hope you understand what is the purpose of the sensor, how it is working, principle, everything I explained. So any doubt regarding the sensor working, and we are not going to use any kind of library here, just simple pure code and some one of the formula here we are using. So that's all about this this sensor. So any doubt regarding this, you may ask now, because we are going to use the sensor in our project. Okay, so that's why it is really important. Any doubt? I just share this code too. Actually yesterday I unable to send the recording, so today I will send that both, because yesterday like my internet is so poor. So that is a project recording only. I also shared the code, so you no need to worry those things. I just Now shared you this code, this one code, so you can see that. I will share this recording too. Okay, no need to worry. Yesterday recording, today recording, I will share both of those within today. I will try that as soon as possible. So, any doubt on this, or else we move to the next sensor? We are going to cover two sensors. Okay, but I will split this recording. Okay, so in this only you able to see about the ultrasonic sensor. So, any doubt on this ultrasonic sensor, you can ask now, or we will move to the next one. No doubt.
No, sir, not right.
Okay. In application, we are going to use that in car reverse parking sensor. So when you are going to reverse the car, then you need to know about what is behind the car. Okay, what object is behind the car. Otherwise, you will hit that object. So for that, you can use the ultrasonic sensor. How much distance the object is placed behind the car, like that. And in robotics, you can use this for obstacle detection, so that robot can know there is an object over there, like that. In industrial automation also, they can able to use like detection in tank, how much the tank is like how the quality, like how the quantity of waters or something like that. And you can use for distance measure smart rulers, like that. And also you can use this as security system, like some object is detected, mean you can set that is some buzzer, like that. So when an object is detected within a range, the buzzer will ring, like that. For a security system is also you can able to use this one. Multiple range of application is for this particular sensor. So that's why I said. So here they have given the sample code also, but we have already worked out, and I sent you the code in our group. Okay, and this is all about like summaries, like work with trig pin. Trig is input, echo is output, as I already said, and the formula they have given. And this is a simple summary you need to revise for this class, this one, ultrasonic sensor one. Okay, that's all. Let's move to the next sensor. That is really like a similar sensor only. That is the next class. We will finish that one too. We have time still. So let's move to the next one. Okay, I will move.